The next talk is Bob Marmon from Evotec. He's going to be talking about building supplier databases. Bob trained as a chemist, did his PhD at Leeds, and he's been working at Evotec for many, many years, he tells me. And he's moved from being a chemist into the eScience group, and he's here to tell us, as I said, about building a chemical suppliers catalogue.
Morning. Today I'd like to tell you about loading supplier catalogue data into EvoSource, our in-house chemical sourcing system, which Ian told you something about yesterday. And I'd also like to show you where we're using Chemaxon tools all through the process. So just a quick overview of our process. As you can imagine, it's quite a cyclic process with new catalogues being put out at regular intervals. So the first thing is we're contacting the suppliers and also always looking for new suppliers. We receive the catalogues from them, and then we have to do quite a bit of preparation on them, including adding names to the catalogues. Then we carry on, we load the catalogue data in multiple parallel processes. And then following that, we go through and fix the errors that we can fix in the catalogues, so we can load as much data in as possible into the database for the chemist to order. And if there's already an existing catalogue in there, we expire the data. So when we started building EvoSource, we initially started to try and build up a big list of suppliers so we could get as many catalogues as possible into the database. And we did a lot of internet searching and looking through our in-house ERP system and talking to chemists. And we came up with quite a long list of over 300 suppliers, but when we tried to contact them, a lot of them no longer seemed to exist. They'd gone out of business, or they'd merged, or something else. So we got down to about 100 that we could actually contact. And so when we contacted the suppliers, we always asked them, can you send us an SD catalogue? So a catalogue in SD file format. A lot of them came back and said, we've no idea what an SD file is. So, but they sent us quite a variety of other formats, often Excel sheets or Word documents with names in, and we've got some name to structure software, so we were able to convert those into SD files, and some of the other ones we were also able to convert. At the moment, ones where we've got pictures in there, so like PDFs or Word documents or Excel with pictures in, we haven't tried to convert them, but that's something we're going to look into in the near future, because quite often we get suppliers sending out flyers that are PDF documents, and the chemists come to us and say, can you load these into the database? So it's something we've got to look at quite quickly. So with the SD files in hand, then we'd like to put a UPAC name in for every compound so that the chemists have got a consistent way of searching in there. At the moment we've been using ACD name structure, but soon we're going to replace this with the Chemaxon structure to name software and have this included in our loading process rather than a separate application. So once we've added the names from them, then we're using Marmon View to check through the data and make sure it's got the important fields for us, like catalogue number and hopefully pricing information and some other physical properties. If we need to do a bit more processing on the file, then we always use InstantJek for this. So in particular, some of the catalogues, like this one originally, had pack size and price in the same column with separators, which was quite inconvenient for our loading process. So we'd be exporting the data out of InstantJek and processing it in a text file and then putting it back into InstantJek. Once we've got our SD file processed and we're happy it's all ready for loading, then we prepare an XML file for each one, which maps the fields in the SD file to our database fields. So we do one of those for each one. And then we've got an application, a command line application that uses the Chemaxon API, which splits the file up into smaller blocks. So we split them up into 1,000 structure blocks because we find that loads much more efficiently. And also it makes it easier for us to do the error processing at the end of the loading process. The loader is also a command line application at the moment. We're going to look into creating a GUI for it shortly, so we can put it out to less specialised people running it. And we run the loader in multiple parallel instances, so we usually run 12 of these, and we can load about 18,000 structures an hour. During the loading process, we run all the compounds through standardizer first, or through standardization in the loader. We do a lot of use a lot of the standard functions of the standardizer, but we've also got 65 of our own transforms where we do various transformations, like making sure the nitro groups are all consistent between our different databases, and also azides. And then we're gradually adding more of these sort of transforms where we're finding in some of the supplier catalogues they've got calcium covalently linked to them, and we like to represent it like that in our database. Also during the loading process we split the salt information away from the compounds, and we have a separate table of the salt information. And we have the desalted structures kept in a separate table for the computational chemists to use because they prefer them desalted. Once we've finished loading, we usually have a number of error files, and we check those in Marmon View to begin with. And then on the command line, we combine the error files and load them into InstantJek. And then we can sort on the type of error and fix the errors that we can. So these are some of the sorts of errors we get in there. Some of these obviously we can fix before we start loading just by checking what we've got there, but we get quite a lot of empty structures in the SD files. And things with incorrect stereochemistry, valence errors, incorrect bonding. So I'm really looking forward to adding the structure checker stuff in that, because particularly we had a lot of problems with compounds drawn with multiple wedge bonds in there where they're not actually got chiral centres in there. So, and we also get quite a few errors with incorrect data in CAS numbers and MFCD numbers. So some of the errors we can fix. Some of them, like these ones, are quite straightforward to fix, because in this one the suppliers put the compound name in there, so we can see that they'd actually intended to put the bromines here rather than there. But I guess when they've got hundreds of thousands of compounds in their catalogues, they find it difficult to go through and check them as well. But some of the ones that we've not addressed at the moment, just because of the sheer quantity of them, we often get things where we've got CAS numbers for two different structures with the same CAS number, and it would take us quite a lot of time to go through and find out which compound's actually for that CAS number. But that's something we want to look into. And often the physical data disagrees with, as Ian mentioned yesterday, sometimes suppliers don't agree on density in there. So again, that would take us quite a bit of work to go through and find that in the literature. I've already mentioned that we haven't started looking at loading compounds from PDFs yet, but polymers are another thing that we'd like to load, because the chemists want to order quite a lot of things like amberless resins and polymer supported reagents, but we don't have a way of representing those in the database at the moment because we're storing things as SMILE structures. And the same with structures with query features. Some of the catalogues are supplied for some natural products where they come as a mixture of compounds. That would be useful. Some of the empty structure compounds like palm oil, that's something again that a chemist would like to order, but we don't have a way of representing it in the database. Organometallic compounds can also be a problem as well, with different manufacturers representing them in different ways. And ideally what we'd like to do there is do a transform in the standardizer so that it would make them all go the same way. And I put mixtures in here as something that we can't load, but we can actually load those, just we choose not to on the first pass, because we like to look at them and make sure that they are actually genuine mixtures, or whether we need to add an extra salt type to our salt table. So this last slide, just wanted to say sort of things that would help us if all the suppliers could let us have SD files rather than various other files. That would be very helpful. And keeping, because we're preparing an XML mapping file for each catalogue, it would be useful if they could keep to a consistent layout between their catalogues. Often they have different spelling or different concatenations in the same field headers. And structure depiction would also help us if people could agree on drawing some organometallics in the same way. Okay, thank you very much.
Thank you, Bob. Finished well ahead of time, so we've got time for questions.
How many compounds do you have in the end in your database? How many unique structures?
It's coming up to 11 million now. So we've been loading since Christmas. We've got data for, I think it's 70 suppliers, wasn't it, in 215.
Okay, any more questions?
I was going to ask you what you thought you might do about fixing those CAS numbers, but if you've got 11 million, I don't think it's a valid question.
Yeah, we need an automated way to fix them, I think. So yeah. It's just too many to go through in the short term. But it's very useful though, because obviously chemists want to search on CAS number. So. Yeah, and we do fix them as people let us know that the number's wrong. So.
I'll ask a question. Are you feeding the errors back to the suppliers? And if you are, what's their response?
Yeah, no, we have fed them back to the suppliers as well, and they've usually been very grateful to have somebody telling them where the errors are in their catalogues.